Today we will be solving the last problem from the tries part, which is word search 2. I think it's a pretty famous problem, so we will be solving this problem. Let's read out the problem first. Okay, so problem says given a m into n board of characters and a list of string words, written all the words on the board. Each word must be constructed from letters sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. The same letter cell may not be used more than once in a word. So I think the question is saying that we have this board. Okay, we have this board and this board of string, I think board of characters, and we are given a array words in which we have words. Like in this array we have 4 words: oath, pee, eat, rain. And what we need to do? Okay, we need to return all words on the board. So out of these words we need to find that how many words, means which word is present in this board. So the output for this particular case is eat and oath. So means these 2 words out of these 4 words are present on this board. So first word is OATH, oath. Okay, and second word is TAE. And we need to find these words. So what are our time constraints? So board is m into n board, where m and n are smaller than 12. Smaller than equal to 12. So at max we can have 12 into 12, 144 characters in on this board. And the length of a maximum length of a word can be 3 raised to the power 4. No, means total number of words we can have is 3 into 10 raised to the power 4, and length of a word can be 1 to 10, and all letters in word are consist of lowercase English letters, and all strings of word are unique. Okay, and okay, so what we can do here is we can store our these words in a trie. For once, let's assume we have stored these words in our trie. So as we know, insertion in a trie takes a time equals to words length, and also searching a word into trie takes equal to the length of the word. So both search and insert will take time equals to the length of the word. So what then, after storing in try, what we can do is, we can suppose start from every word. Suppose here we start from O, and we will look for it in a try, whether it exists in a try. Then it will exist in a try, so then we will move to next adjacent cells. Suppose first we move to E, then we see whether after O E is present. So E will not be present after E, so we will not go further in this path. Then we will check if A is present. Yes, A is present. Then what we will do, we will go to T. Then we look for T, if T is present in try or not. So I think in that way we can solve this question. So approach would, steps would be something like, store words in try. Okay, and then next step will be iterate board and start from every let's say every character, and look in try. So storing and searching in try would take how much time? So we have in total 10 raised to the power 4 words, 3 into 10 raised to the power 4 words. So storing in try would take 3 into 10 raised to the power 4, and as we know, storing a word will take time equals to its length. So the maximum length of a word can be 10, so into 10. So this will give us time complexity of 3 into 10 raised to the power 5. So that equates to 3 into 10 raised to the power, wait a second, 3 into 10 raised to the power 5. So that's how, so these are expected, means acceptable time complexity. Similarly, what we are doing, we are only iterating words fully if that word present in try. So that means we will be only iterating words that are present in try. So this function which we will be creating will also gonna take this much time. So solutions below equal to 10 raised to the power are acceptable in on LeetCode at least. So let's first create a try. So we will define our inner class in solution, public class try node. So a try node will, as we only have a lowercase English letter, so our try node will have only 26 children. Try node 26, and we will define a boolean that as a end of the word, so word end. And in our constructor we can define this word end as false. This will be initial value. And also what we can do, we can pick this up. So this will be our try structure, try node, and we will define functions for adding in a try. So public void add. So add function will take a string, let's say word. We need to add a word into our try. Okay, this is our try node. We separately need to define our try class, public class try. So a try will consist of a try node head, and after initializing this class we will initialize this head as new try node. So our try will consist of a try node, and here we need to define our function public void add, and we need to add string word to our try. So we have initialized this we have initialized our try, which is this try node, and we will take a temporary variable and we will add our word character by character into this try from 0 and I less than word dot length I plus plus. So our current character will be character ch will be word dot character at ith position. So we have defined our current character, and we will check if temporary nodes children and this position means we are using 0 base indexing, means we are using 0 for a and 25 for z. So we will check if a try node is present at this position or not. If it is null, then we will put a try node here, means having a try node will represent that this character is present at this position. So what we will do, at this position children ch minus a, we will put a try node, new try node, and we will move our temporary variable to this children. And after adding this word, that we have added this word, so now what we can do, we can make our temporary variable dot word end. So this is our word end, so we can mark it as true. So we have reached the word end. So similarly what we will do, we will use a search function. I think here we don't need to implement search function. We will see why we don't need to. We will implement it in this iteration part itself, in the recursion part itself. Okay. So this is our try node and this is our try. So what we need to do is we need to initialize our try is equals to new try. So this will initialize our new try head node. So we have initialized our try. Now we will add these words to our try. So for int for string current word in words, we will call add function on our try, and we will add this word into the try. So this function will add word to our try. So our first step is done, that we have stored words in our try. So this is a template for the try. So this doesn't contain a search function. So this is a template for our try function, which we can use everywhere, wherever we are implementing try. So now we need to move to this second step. We need to search our board. So what we will do, we will create a list of answer, means the words present on board. So let's call this answer, and let's initialize this as a new array list. And at the end we need to return this list. So now what we will do, we will call our dfs function. We will iterate our this board one by one. So initially we are at 0th cell, 0 comma 0th cell, and we will pass head of our try, okay, and we are 0th cell, and we will pass our board, and we will pass our answer. So I think these arguments will be sufficient. So public void dfs, so int ith cell, int jth cell, and try node head board characters. This is our board, and our answer will be a list of string. Okay. So we will check what character is present at board's ijth position. So we will call this character as current. So this character is present at ijth position. So we will check if this character is present at our in our heads children or not. So if okay, we need to iterate the board and start from every character which is present in try. So instead of doing this, what we can do is we can iterate our board. Int I is equals to 0, I less than board dot length I plus plus, and for int j equals to 0 and j less than board 0 dot length and j plus plus. We can check if our try dot head dot children board ij minus a, means if this character, if it's not null, that means in that case we can call our dfs function. That will be more efficient, means we will be calling our dfs. We will check that word starting from o or a exists in our try or not. Okay, And we need to while transversing this board, we need to also track of visited cells, that so that we don't revisit a cell. Let's call a array, boolean array visited, that will be equal to board dot length and board board 0 dot length size. Okay, and we can create a boolean array here, visited. And what we can do, we can mark our current ij index as visited, that we have visited this index, we don't need to visit it further. So we have visited this o index. Now we need to move in all four directions. So to move in all four directions, we will create a direction vector, as I have explained in previous videos also. So what a direction vector will do, it will help us to move in all the four directions, left, right, horizontally, vertically. 0, -1, 0. This is not a rocket science. Once you need to means revise this or learn this, this will be helpful in many problems. So means all the DFS problems, this will be helpful to move in all the four directions. So our current cell is ij, and from this ij cell we will find this cell means right cell, bottom cell, left cell, and top cell. So what we will do, we will move in this directions vector dir, directions array dir, so I plus dir of 0 and y will be j plus dir of 1. So in this way we will get all the four directions. So we will call our DFS function. Okay, we will call our DFS function, and for x and y we will call our DFS function. We have called our DFS function, and we will move to a next direction. So before that we need to verify if our x and y are valid. Our x needs to be greater than equal to 0, and y also need to be greater than equal to 0, means so that these don't go out of the boundary of this board, and smaller than board dot length, and y needs to be smaller than board 0 dot length, lenghg. Okay, and also if these checks passes, the cell which we are going to visit should not be visited, xy. Okay, the cell should not be visited, and in our try, heads children and character at that board, board, xy minus a should not be null. Then only we will move to a direction. Suppose we are at O position. This uh, iterating in this for loop, we will get all the four direction A, E and two invalid position which will be here and which will be on the left. So we will avoiding that too by these conditions, and we are then moving to uh, A position. A and E both are not visited, but this check will only move to A direction as A is only present in try. OATH is a word. So then we will move our DFS function. We will pass x, y and our head dot children means this position we need to pass. Means to this children we are moving. Board, answer and visited. And after iterating this O, we will mark it as unvisited. This will be backtracking. Visited of ij will be false. And whenever we reach, means whenever our head dot word end becomes true, in that case we have found a word and we need to add that word to our answer. Answer dot add that word. We will not return because a multiple word can end, so we will not return. So what we are missing here is we are missing that word which we need to add. So we also need to pass a string. Means along with that answer variable, what we can pass, let's say we pass an empty string. So that will be our string current word. So we will add that current word to our list. Current word plus, let's say, plus board of ij, and we need to pass that current word okay. We need to add that current word and we need to pass that current word from here at this position. Current word we will add to this current word board of xy. plus board of xy. And here also, instead of doing this, what we need to pass is we need to add a character ij. I think we have implemented. Let's run. Okay, we have got error length length. Run. Okay. Case 2 is output is nothing, but in case 1 we are getting this extra string r. So do we need to extra string e? We are getting e here. Why we are getting a e and r? We are doing some mistake while adding our string. So where is our test case results? This will be your current word. Then we are adding some word to it. For string words we are adding the word to the try. After adding, I think our try structure is good. We are iterating our board. Then in board we are checking if this children is not null. Means we are creating this head. Okay. For int I j equals to 0, board dot length j plus plus try dot head dot children board ij minus a null. That means we have found a word. Okay. we are only passing from this variable only if our x and y are valid positions. So suppose we have a word RV. When we come to R position, what we will do, we will add our R. Okay. We will come to our R position. Then we will move on in all directions and we will come to V. We come to V and we will from here we come to V and we add V here. And then we see if the word is ended. But in that case our word will not be ended because we are adding it to the let's say in this test case if we want to find RV, I think in that case our code will not return any answer. Okay, it's returning nothing because our word is ending first, then it will moving to that position. So we need to move these checks here. Instead of I, we will XY. Let's call them J. I and J. Okay. I, J should not be visited. And their children should not be null. What we will do if I is smaller than 0 or J is smaller than 0 or I greater than equal to board or J greater than equal to board, or if it's visited current position and or if it's a null, then what we will do that this current position our is not valid, we will return. Otherwise we will add to our current word the current character, that would be board of ij, and at the end we need to remove that. How we can remove? We can make our current word as current word dot substring 0 to current word dot length -1. So this will remove last character from our current word, and then we don't need these checks here. Let's see if this rv means we are looking for rv in our board, this board. So this board contains r and v. So let's see now if it's giving correct output or not. Okay, we have some compilation error. Okay, we need to pass an empty string here, or we can call it as a new string. Okay, we have some issue here. Cannot find symbol in try. xy. Okay, this should also be ij. Okay. Okay, our head is null. Head should not be null. We need to pass here children of I and j. Okay, so we have found this word. Let's reset our test case and see if this works. Okay, we have found the word multiple times. Means we are getting correct output, but we are getting word multiple times. Or head dot children board of ij minus a is null. Okay. We are putting this after one children moving after our word in our try. What if we check if our I is word dot length minus 1, that means this is the last character, and at this that position if we put this ending position, then okay, then also we are not getting the expected answer. We have passed current character. It's not words and let's modify this test case again as RV. That small test case will help us to debug it is faster. Okay, so we have RV. So what we are doing, wait a second, what we are doing, we are passing a R. Means first we will create our tree. Let's move it at the end of the where it was. So we have created a try, and what we will do in heads children, in head objects children we will put a try node at our position. Now we will move to this node. Okay, now we will assign a we are creating a new try node head. In that head what we will have a children and a variable word end. So at our position what we will do, we will put a try node. That means we will put a word end we will put a word end and a new object, and in this new object what we will do, we will put at v position a new try node, and we will mark that end as true. So we will look for r will be present, then we move to this v is present, then we move it to this position. This position will be true. Okay, so in our function call, what we are doing, passing empty string and ij are at let's say this position r. We will see if its position is valid. Yes, it's valid and not visited till now, and our head variable will not also be null, and children at ij position will not also be null. Then we have added our current word r and marking visited as the true. Okay, marking r as the true, then we will move all the 4 directions and then we reach to this position v, and now our new head will be this variable. Okay, now in this variable we will be checking our new x and y will be this. We will validating again and checking if it's not null, so it's not null. It's not null, but our word and will not be true. And we will move to next positions. We need to check this word, and I think children at this position dot word, and we have moved it outside. Children, what issue we are having here? What's the issue? Do we have any syntax issue here? Illegal start of expression. Okay, we need to have a board here. Okay, we are only able to find r, means we are missing the last word, so we will be also missing last word in the previous cases also. Okay, we are missing last word now, so we need to make that last word. We need to add that last word also. Okay, so I have got an idea. Instead of doing this here, if our head is not equal to null and an end, if it's a word end, then we can add our word. Why we are getting multiple word ends here? We can, this is not a problem, we can use a set, but why we are getting multiple answers? Means we can do this here. But this will not work, I think. Okay, we are getting wrong answer. We are getting multiple. So what we can do is, what if we decide to return here, but this will cause a issue like two strings having similar prefix. In that case it will create a issue. If we make it as a set and return a new array list, let's submit this. This is working, but I did not want to use a set. I don't want to use a set here. I just want to iterate these only once. So let's see how GPT can help us. Try construction. Second is DFS search. Avoid using new string. Okay, string using string builder. We can use a string builder. I don't want to use answer set. Can we do it? Okay, so it's not also efficient. So I think our current answer is good. We can also have some. Okay, it's a Java solution. So I think our solution is correct. We can look up for further optimization. So I think that is it for today, and we have completed our try section. So from tomorrow we will be again live streaming, and we will be trying to solve this remaining advanced topic as soon as possible. Thank you.